Hello, everyone, and welcome to Hoot episode number 44. My name is Peter, and I'm a developer advocate at Solo, and today I'll give you an overview of SPIRE. So the support for SPIRE in Istio was announced in Istio 1.14, that was back in June last year. And what SPIRE enables us is to use strongly attested identities by using a combination of different attestation mechanisms. Throughout the live stream, feel free to ask any questions, and every once in a while, I'll look down and see if there are any, and I will answer them. All right, so I have a couple of slides, so I'll go through those first, and then I also have a demo, of course, and we'll go through the demo a little bit later. All right, so let me share my screen. Hopefully the slides will show up. All right, so let's get started with the definition of SPIRE. Every time I look into some new technology, I like to start with a definition and then break that down into different components and then figure out what those different components mean and how everything works together. All right, so SPIRE is a production-ready implementation of SPIFFE APIs that perform node and workload attestation to securely issue SVIDs to workloads and to verify SVIDs of other workloads based on some conditions. So depending what your background is, you might have heard of SPIFFE before, you might have heard of attestation, and you might have even heard of SVIDs. But let's start with SPIFFE first. So SPIFFE stands for Secure Production Identity Framework for Everyone. And what it does is it defines a framework and a set of standards for identifying and securing communication between workloads. So someone's asking about slides. I guess we can share the slides. I don't see why not. I'll also share the demo. It will be in Hoot's GitHub repo. All right, so we said the SPIFFE is a production identity framework and defines a set of standards for identifying and securing communication between workloads. So a workload can mean a lot of things. So it could either be a web server, a database, a backend API, and it can run in a container, virtual machine, or in a cluster. So the part that's important here is that in the SPIFFE world, a workload is typically more fine-grained than a node, right? And this is important, especially for environments where you have multiple workloads that are running on a single node, like Kubernetes. So at a high level, SPIFFE defines three things. So it defines how services are identified, and it uses, and for identification, it uses a unique string that's called the SPIFFE ID. So the SPIFFE ID is a combination of a trust domain and a workload identifier. So SPIFFE : //cluster.local, which is the trust domain, /NS, which stands for namespace, /name of that namespace, default, /SA service account, /sleep, which is the name of the service account in this case. Secondly, SPIFFE also defines how these SPIFFE IDs get encoded into SPIFFE verifiable identity documents, or SVIDs. There's a lot of SPIFFE here. So these documents can be in two forms, either as X509 certificate or a JOT token. So whenever someone's talking about SVIDs, they're either thinking about X509 certificate or JOT token. So these SVIDs, or these documents, these files, are then used by the workloads, and workloads provide their identity to the callers, right, with using these documents. Finally, SPIFFE also defines how SVIDs, how these documents can be issued, and this is what the Workload API specifies. So let's look at how the SPIFFE IDs get encoded into SVIDs, into these documents. So when we have, and of course we'll talk about Kubernetes. So everything I'm talking about here is going to be mostly Kubernetes and Istio world. So when we have Istio installed, we know that Istio automatically provisions identities for every workload that gets deployed. And this identity is based on the Kubernetes service account. And this, together with the trust domain and the namespace the workload is running in, gets encoded into the SVID, the X509 certificate. Now, where that SPIFFE ID gets encoded or included in is defined by the SPIFFE spec. So the SPIFFE spec for the X509 SVIDs is saying that the ID has to be encoded in the subject alternative name field, and the SPIFFE ID has to have a specific URL format. So it starts with SPIFFE:// followed by the trust domain, namespace name, and then the service account name. Now, additionally, when we talk about Istio and, of course, Envoy proxies, there's also a little bit of extra logic that's implemented in the proxies themselves that, in addition to doing the typical certificate validation, they also verify or check that subject alternative name field for the SPIFFE ID. And then last thing was just, so this explained the first two components, the ID and the SVID, and the last one was the workload API. And this one just describes how these SVIDs should be issued. So to recap SPIFFE, so SPIFFE is a set of standards, and these standards define how we can securely identify workloads. And then SPIRE is just an implementation of that specification. So another project you might be familiar with that implements SPIFFE is Istio. So let's look at the details on how SPIRE works. So there are a couple of different components that make up SPIRE. At a high level, we have the SPIRE server, and then we have a collection of SPIRE agents that run on different nodes. Now, both components expose an API. So when we're talking about server, there's the registration API that's used for automatically or manually registering workloads through registration entries. And then there's the node API that the agents use to communicate with the server. On the agent side itself, there's also an API that's called the Workload API. And that API is what the workloads talk to. They talk to the agent through this API to obtain these SVIDs, these X509 certificates in case of Istio. So the SPIRE server also acts as a signing authority for identities and then issues them. It uses agents to issue these identities to different workloads. Now, amongst other things, the server is configured with a specific trust domain, and that trust domain then becomes part of the SPIFFE ID. And we'll see this later when I do the demo. So the example here is the example.org trust domain. By default, the server generates a self-signed certificate, and then it uses that certificate to sign the SVIDs for workloads. However, there's a plethora of different plugins that one can use. In this case, if we want to use our own CA credentials, we could use the Upstream Authority plugin to do that. Also, the other aspects of these components are extensible through different plugin types. So there are plugins for attesting the nodes, attesting the workloads. There's the data store plugin that allows us to use different persistent storage like MySQL, SQLite, or Postgres. There's the key manager plugin for signing and key storage logic, and then the Upstream Authority and the notifier plugin. I'll show these in more detail when I go through the demo. So if we go back to the original explanation of definition of SPIRE, we've talked about SPIFFE, we've talked about SVIDs, but we haven't mentioned node and workload attestation. So attestation is the process of establishing identity of either a node where the workload is running on or the workloads themselves. So with the node attestation, the SPIRE agent and SPIRE server work together to verify the identity of the node that workload is running on. And the way to do that is by using the node attesters. So as an example, I'll just use AWS node attester plugin, right? And that plugin knows how to query AWS to get the proof of the node's identity. So the SPIRE agent is going to make a call to AWS in this case, and it's going to get back the proof of node's identity. Now, in addition to AWS, there's also node attester plugins for Azure. There's node attester plugin for GCP, as well as for Kubernetes clusters. So once agent has this gathered proof, it's gonna send it over to the server, and then the server is gonna use AWS node attester plugin again to validate that identity independently from what it heard from the agent. So once the identity is validated, it's going to create a SPIFFE ID, and then it's going to send that back send an SVID back to the agent, and then agent is going to use this SVID to talk to the server through mutual TLS. So this is agent themselves identifying themselves and making a secure connection with the SPIRE server. Now, in addition to node attesters, there's also a collection of optional node resolver plugins on the server side, and those can be used to gather or extract additional properties of the node and then turn those properties into selectors. For example, Azure Node Selector or Node Resolver is going to return the subscription ID, is going to return the VM name, network security group, and then all the other properties that are associated to the node or with the node. Now, the combination of these selectors are then associated, in this case, with the agent's node's SPIFFE ID. So on the image on the slide, I have an example of this registration entry, and in this case, it's for a node. So the parent ID of this registration entry is the SPIRE server. So we're using example.org as the trust domain. And then above that, we have the SPIFFE ID that represents the node. Now, if you look at the string, you can see that the trust domain is the same. There's a name, there's a string there that says Kubernetes Workload Registrar. We'll talk about that in the demo. There's the name of my cluster, which is the demo cluster. And then there's the node and the identifier of the node. Now, at the bottom, we can also see two selectors that were created by the Kubernetes node attester. So the ID of this attester that gets followed by the node UID, and then the second selector represents the name of the cluster. There's node attestation. There's also workload attestation. And workload attestation is similar, but instead of identifying the node, what we're trying to do is we're trying to identify the workload. So the SPIRE agent uses the workload attesters to determine the workload properties. So things such as user ID, group ID, service account, namespace, pod ID, et cetera, et cetera. And then these properties are returned back from these attester plugins in the form of selectors, just like with the node. And we can see the selectors that get extracted on the slide. I have a screenshot that shows the three different selectors that were extracted for this specific sleep Kubernetes workload. So we have the node name the workload is running on, we have the namespace names, and we have the pod UID. Now, what agent does then, it compares these selectors. So when the workload calls the agent and says, hey, this is me, right? It does the workload attestation. The agent can then compare these selectors to the registration entries, to the selectors from the registration entries that it got from the server. And if they match, then we know which SPIFFE ID and the correct SVID that's going to get issued to the workload, right? So basically, your workload is saying, this is my ID, I'm in the default namespace, and this is the node that I'm running on. Now, independently, the server and the Kubernetes registrar, in this case, did a inventory of all the workloads in the cluster, and it also independently gathered those selectors, right? And then those two are get matched, and if they match, the SVID gets issued for the workload. So this was very non-Istio specific, I guess, maybe a little bit, right? It was more Kubernetes specific. So let's look at SPIRE with Istio and this combination. So when running workloads in the mesh, most of them, all of them are deployed. If you're using Kubernetes cluster, they're deployed as Kubernetes pods. And within that pod, there are typically two containers. You have the app container and you have the sidecar proxy, the Envoy proxy. Now, if we go one level deeper, one step further, the sidecar proxy is actually made up of the Envoy proxy, the binary, right? And a binary called Istio agent. So that Istio agent is actually responsible for bootstrapping the proxy, launching the proxy, as well as for provisioning the identities to the workloads. So what Envoy does, it uses Secret Discovery Service, or SDS, to talk to the Istio agent whenever it needs any secrets, whenever it needs any certificates. So the Istio agent is going to create the private key and the certificate signing requests, and it's going to send that to the Istio's control plane for signing. So IstioD validates the credentials and then sends the signed certificate back to the Istio agent. Now, the Istio agent typically acts as an SDS server that gets mounted on the Unix domain socket. And this is where the Envoy proxy, so Envoy proxy uses a well-known location path for the socket. It connects to that socket in order to receive the secrets, in order to receive the certificates. So the Istio agent is also then responsible for managing the lifecycle of the certificate, and it will rotate the certificate before they expire. Now, by default, if you bring up a Kubernetes cluster, if you install Istio, if you deploy a workload, the Istio agent will automatically, by default, start this SDS server. However, there is a logic in the Istio agent that's going to check whether that socket already exists. And if it doesn't exist, the SDS server gets started. However, if the socket is there and it's responsive, the SDS server isn't started, which means that instead of connecting to the SDS server that's launched by Istio agent and implemented by Istio agent, Envoy can talk through the socket to something that implements the SDS API. And you might have guessed that something is the SPIRE agent. So this diagram looks very, very similar to the previous one. So Envoy is still using the same socket on the same path to talk to the SDS to get the secrets. However, this time the implementation is in the SPIRE agent and not in the Istio agent. So once this is connected, then SPIRE can stream back the certificates to the Envoy proxy. So SPIRE agent is going to do what it does, makes a call to the server, etc., issue SVIDs, whatever, and then send and stream them back to the Envoy proxy. All right, so this was like very high-level basics. So let's look at the setup that I'll be using today, and then I'm going to go through the demo and explain stuff even in more detail. So I'll be using a Kubernetes cluster. I'll have 3 nodes, and then we'll install the SPIRE server and we'll install the SPIRE agents. And one thing to note here, the SPIRE server, and we'll see in the YAML, also runs an additional container that's called the SPIRE Controller Manager. And the SPIRE controller manager is the one that's responsible for automatically registering workloads in the cluster. So there's some webhooks, and whenever pods are brought up, and there's also a way to target specific pods, right? We can say, oh, I only want to register the workloads or the pods that have a specific label set, right? You can do all that. You can control all that. But this is what SPIRE server uses to create the list of registration entries. And those are then later used in the combination with selectors to issue or to. So Age is going to send the selectors, is going to match them to the registration entries, and is going to send the SVID if there is a match. All right, so let me stop sharing this and I'll share a different screen. If I can find my Zoom control here. There I go. If there are any questions, feel free to ask. There's only a question about slides. Yes, slides will be available. We'll post them somewhere. And I have also a bunch of resources in forms of links that I wanted to share with everyone in case you want to go through this on your own. All right, so I have this demo. Note that if you go to Istio 114, if you go, there was a blog post, there's a tutorial in Istio.io. However, Istio, the tutorial over there is still using a little bit of an older version of SPIRE, where they use the Kubernetes registrar to register the automatically register the workloads. However, that has changed, and now they use the SPIRE controller manager. And this is what I'm using. So this is bleeding edge, I guess, if you would say it that way. All right, so I have a cluster. So let me just show you. I have a cluster with 3 nodes. Cluster's name is Hoot-SPIRE, and this is important because we'll set this is going to be our cluster name, and this is something that we'll set in different YAML files. So we have a cluster. I don't have anything deployed. Whoops, I don't have anything deployed. Just pure Kubernetes running on Civo Cloud. Thanks, Civo, for your product. It's very fast to bring up clusters there. All right, so the first thing that we'll do, I have the script. This is just prerequisites, and I'll go through the YAMLs a little bit just to explain what everything is. So I've created a namespace called SPIRE. This could be, of course, whatever you want. Just make sure you change it in all the YAML files as well. And the first thing that I'll do is I'll deploy this CSI driver. So let me open this one. So what this CSI driver is, like I've mentioned in the slides, that the SPIFFE workload API is basically served over the Unix domain socket, right? And in order for the Envoy proxies to connect to it, we need to inject that workload API socket into each pod. Right. So what we're doing is we're using this container storage interface driver for SPIFFE, and this allows us to mount the same folder, the folder that contains the socket, as an ephemeral volume into each pod. So that's all it is. I'm not going to go more into that. So let's deploy this one, the CSI driver. Then we also have a set of CRDs. These are SPIRE CRDs, and we'll see one of them later. There's the cluster SPIFFE ID. I'll show this later in the demo, but there's also CRDs if we want to do the federated trust domains with SPIRE. So we can do that as well. So let's do CRDs next. And then we have the controller manager, right? We have the controller manager configuration and the controller manager webhook. So let's look at the config first. So this is just creating a config map, and then that one is going to be, the config map is going to be mapped into the SPIRE control manager that's going to run as part of the SPIRE server. So metrics, health probe, leader election in case there's multiple SPIRE servers running, cluster name. So in my case, just want to make sure that this is correct. It's Hoot /spire, because if this is wrong, then stuff is not going to work. And then the trust domain, I just picked hoot.solo.io, could be whatever we want. And then we can also specify the namespaces we want to ignore, the namespaces we don't want to create registration entries automatically for, right? So don't have to specify these. These are specified by default, so I left them there. And then we have the validating webhook configuration. One is for the federated cluster domain, and the other one is for the cluster SPIFFE ID. So later we're going to create a cluster SPIFFE ID resource that's going to define for which workloads we want to automatically create the registration entries for, as well as the format of the SPIFFE ID. All right, so let's do these two next. And these are all the prerequisites. All right, so we have the prerequisites there. Next one is we're going to deploy the server, the SPIRE server. And let's look at it. There's a couple of cluster roles, role bindings here, config maps, not going to go through that, but we'll go through this stateful set that runs the server. So there are two containers running here. One is the SPIRE server itself. So it's just a server with the config. Actually, we are going to look at the server config, right? So let's go through a config first. Trust domain, note that this has to be the same as we've said it before. Bunch of different settings here. We can also set the federation if you wanted to for the bundle. And then this is where you define the different plugins, right? So we have the data store plugin that's just saying we're going to use SQLite 3, and this is where the database is going to be at. We're going to use the node attester for Kubernetes, right? And I have a to-do here that says update the cluster name, and I think that is the cluster name that we're using. Hoot SPIRE, yep. And we can also specify the account allow list. This is just saying which service accounts can connect back, which is our service agent. Key manager, going to be keys on the disk. And then we have a notifier that's called Kubernetes bundle, and it's just pointing to the namespace. So what happens when server starts up for the first time, it creates the trust bundle. And what this notifier is saying, well, when you create that trust bundle, store it as a config map in this namespace. And then this config map is going to be used by the SPIRE agent to make that initial connection back to the server. And then there's health checks as well. All right, so let's go down here. So SPIRE server runs with that config, just mounting the volumes in, nothing too crazy here. And then we have the SPIRE controller manager, and this is the one that's going to automatically register all the workloads. This one takes in the config that we saw earlier as well. And then just a couple of volume mounts just to mount those configs. And that's pretty much it. There's also a service, right? Of course, server needs to be exposed, and clients are using this to talk to the server. Yeah, so that's all there is to the server. Know that there's different, like if you want to customize this, or if you're not running this in Kubernetes, if you're running this like outside of Kubernetes on VMs or wherever, this is typically where you will make the most changes, right? This is where you define your node attesters, right? The key managers you want to use, and so on. All right, so let's deploy this SPIRE server.yaml. Okay. All right, so this created everything. Let's just look at the SPIRE namespace. So SPIRE server here, it's still pending. Probably gonna take a minute or so. So let's just wait for that to come up. I guess while we're waiting, I could explain the agent next. Just like the server, agent has configuration as well. The important parts are the server address. So this is just telling it, hey, this is where the SPIRE server is. This is what the server port is. We're telling it where to expose the workload API, which socket path is it going to be. And this is the same one that Istio agent expects it to be on, right? So that's the one. Trust bundle path. Again, this is that bundle CRT that gets created as a config map through the notifier plugin from the server. We have the trust domain, which is the same everywhere. And then we have the node attester plugin. Cluster is the same cluster name as before. Key manager, just using the in-memory one. And then workload attester, just setting the plugin details for the workload attester itself, and then the health checks. So the agent runs as a daemon set, meaning it's going to run an instance on every node that you have. And that agent is going to be responsible for all the workloads running on that specific node. So there are a couple of more, like 2 more containers running in the agent. The first one is just the agent itself, same as the server, just runs the agent, runs the binary, and then passes in the agent config. And there's also the container that runs the SPIFFE CSI driver and the CSI node driver registrar, right? So these two, you can think of these as, this is what allows us to use or allows us to mount that socket into every pod that we have running in the cluster. And this is just a definition of the volumes down here. So while I was talking, the server is up and running now. So let's see. Just going to copy a command here just to get the pod name, even though the pod name is fairly simple because we have the stateful set, right? And then one thing that's good for debugging is there's a SPIRE server binary inside the SPIRE server container that we can use to like see all the registration entries, see all the agents, etc. So let's just run this. Oops. Oh, probably missed the. Is it opt bin? Let me figure this out. Something had to go wrong eventually, right? Let me just see, find where the binary is stored. I thought it's going to be under opt bin SPIRE server. No. All right, well, I'll figure it out where it is. SPIRE server. I'm just doing some searches here just to find where that binary is. Let me see. So opt SPIRE bin. There you go. Maybe this one. No. What am I missing? Oh, this one. Oh, there you go. Yeah. Oh, I guess I don't have to specify. It's bin. What did I miss? Anyway. Command history to the rescue. All right. So the SPIRE server acts like a CLI, right? And there's a bunch of commands that you can run here. So let's run the agent one, and then we can do agent list, and this is gonna show us all the attested agents. We don't have any, right? Because we haven't deployed anything. And there's also the entry show, which is just going to show us all the workloads that were registered, right? And we have 0 here as well. All right, so agent, we explained the agent. So let's deploy the SPIRE agent now. Okay. And wait for it to come up. Let's just do -W here. All right, that was fast. So oh, there you go. So you have these 3 running. We have the SPIRE server running. And now we can look at the entries, the agent, the list of agents. And there you go. We should see 3 of them, right? The SPIFFE ID in form of the trust domain, SPIRE, agent, Kubernetes, a tester. Then we have the cluster name, which is Hoot SPIRE, and node ID. It's showing us the attestation type, it's showing us the serial number, and we have 3 entries there because there we have 3 agents. If we would scale up the cluster or add more agents, we would see them there. All right. Okay, so we have the SPIRE agent as well. So the last thing that we'll do, let's deploy Istio now. So I'm going to use an Istio operator. I have the trust domain set here in the mesh config. I also have the mesh ID and the multi-cluster. Cluster name is different. So cluster name is Hoot.Spire, I think. I always forget the cluster names. No, it's Hoot-Spire, yeah. And then what we're doing here is I'm creating this template called Spire, and this is a sidecar injection webhook, right, template. And what we're doing here is we're just creating a volume that's coming from that CSI driver that we deployed, calling it workload socket, and then just mounting that under this path inside the Istio proxy container. So this is what we're doing with this. We're saying, hey, whenever we deploy, we create a deployment that has a specific annotation set called Spire, and we'll show that. Inject this, right? Inject this section in there, which just mounts that workload API, right? And then this will make the Istio agent not create the SDS server, and Envoy proxy is going to use this socket to talk to the workload API. And then the same thing here for the Ingress gateway. We're just using an overlay, mounting the patching the deployment with this volume, creating the volume, and then just creating the volume mount to mount it at that path. All right, so let's deploy this. So Istio, CTL, and I'm using Istio 1.16.1. There you go. We don't have it running, so we're just doing install Istio, Spire config. Don't get prompted. Okay. This is going to take a couple of seconds. And then the next thing that we'll do is we'll deploy this cluster SPIFFE ID resource. And we're just going to tell Spire, hey, we're going to use the service account based. And we're back. Sorry, everyone. There was a glitch. Hope everyone is still here. So let me reshare my screen. All right. Looks like we're back again. Yay, perfect. Okay, so this is where I left. Oh, looks like our deployment didn't install, but let's talk through the cluster SPIFFE ID resource here. So what we're saying here, telling it to SPIRE, is we're saying we want you to use, for the workloads, right? We want you to use this SPIFFE ID template, which is in the format of trust domain / namespace, pod, namespace, service account, and then the service account name that the pod is using. And then we also want to include the DNS name template. And this is something that gets included in the X509 certificate as well. Now I have this another example here. This is just from the SPIRE's GitHub. It's the same thing, but you can specify a different SPIFFE ID template, right? There's nothing preventing you from doing something like this. It doesn't really matter. But what's really nice is you can set this pod selector and the match label. So this is basically saying any pod that has banking equals true label set, this is the SPIFFE ID template that we want to use for those pods, right? So it gives you, it's very flexible, and it gives you a different way to define your SPIFFE IDs. All right. So it looks like there's some double sound here. I'll close. Hopefully this is better. I hope. I am muted on YouTube. I'm sorry for the technical difficulties. All right, so let's see, why is this complaining here? So I'm just gonna do this, and we'll say get pods. Oh, probably because we didn't deploy the cluster SPIFFE ID. So this one is failing. So let's just look at the logs. Istio system. All right, yeah. So it's failing to. So workload is not authorized for the requested identities, right? And that's because we didn't deploy the cluster SPIFFE ID. So let's deploy this one. Paste. There we go. So we have the cluster SPIFFE ID deployed. And let me see if I can just restart the pod, or if we have to redeploy. Hopefully this will come up. Just creating the container. There we go. Now it's up and running. So the problem was that SPIRE agent, SPIRE server had no clue which SPIFFE ID template to use. It didn't know what the workload was, especially because we injected, remember, we explicitly injected this socket, right, for the Ingress gateway. We haven't done it for STOD, right, because we only do it for the ones that are annotated with the SPIRE template. Okay, so let's look at the, so I wanted to look at the SPIRE server. So agents, there still should be 3, but we can also look at the entries now. And you'll notice that we have 2 of them. So we have the entry for the Istio Ingress gateway. So this is that DNS name that was defined here. So pod name, the selector, the pod UID, and then the actual SPIFFE ID that will get issued if these selectors match, right? So the SPIFFE ID is our trust domain, namespace name, service account name. And then we also see the parent SPIFFE ID. So the parent SPIFFE ID of the parent, rather, which is the agent that's running on this specific node. All right, so let's deploy a sleep workload. So this is the sleep work. This is just the YAML that you will find in like Istio repo. The only difference is here, right? This is where we're defining that extra node, extra annotation or extra template that would define the SPIRE, called SPIRE, right? We're saying that this is a sidecar, and we're saying we also want to use the SPIRE template. Everything else is exactly the same. So before I deploy this, I have to label the namespace for Istio sidecar injection. So let's do that. And then we can now deploy the sleep workload. And then let's take a look once it comes up. Okay. There you go. So it's up and running. I'll just grab the pod ID. And then what we'll do is first, so let's look at the entry, and we should see the entry for the sleep pod as well, which is up here. There you go. Right. So there we only have 3 entries. And then finally, we're going to use the Istio. I'm just going to paste the command, and then I can explain it. So I'll use istioctl proxy config command to get the secret portion of the pod. So this is just going to the Envoy configuration, Envoy proxy, and it's just returning the secret portion of the proxy configuration, and then just parsing it down to the TLS certificate. This workload is running. We're decoding it, and I'm just storing it into this sleep.pem file. So there you go. So let's look at it here. It's just a typical certificate. Now, if we use OpenSSL to decode it, and then we can look it up here, we'll see that the issuer is solo.io. So this is something that I've defined in the agent. The subject is SPIRE. And this also includes the name of the pod. And then down here under subject alternative name, we'll see that DNS entry. So this was DNS entry that was created by this configuration up there. And then we also have the SPIFFE ID, hoot.solo.io/ns-default/sa/c sleep. All right, so this was my demo. I have a couple of more slides, just some high-level things. Let me just find this again here. You share. What was this one? Yeah. Okay. All right. So this was our Kubernetes setup. So what can we do using SPIRE, right? If we start thinking, okay, I have one cluster, right? It's running inside the cluster. Stuff is fairly straightforward when we only have one cluster, I guess. But where it gets interesting is, what if you have multiple clusters, or what if you want to add a VM to our setup, right? So this was the stuff on the right on the slide was our setup today. Since one node, we had additional node there, right? But we had the SPIRE server and 2 or 3 agents, right? But now if you deploy a VM, right? If you want to bring a VM workload and make it part of your mesh, you would deploy the app, you would deploy the sidecar, and then you can also deploy the SPIRE agent there, right? There's nothing preventing you from connecting that SPIRE agent to the SPIRE server, right? There's nothing preventing you from running that SPIRE server as in like a separate either Kubernetes cluster or VM or wherever you want to run it, right? Have a central identity server, and then have all your agents connect to that central SPIRE server for their identities and SPIFFE IDs. And then there's nothing preventing you from adding either more VMs or more clusters, right? It's very it's platform agnostic, and it's very extensible, I guess, and you can mold it the way you want. You can come up with different architectures. A couple of interesting one here are the nested SPIRE, right? So you can have layer 1 SPIRE server, if you want to call it that issues identities to SPIRE agents, and then those SPIRE agents in turn issue or are responsible for identities of your level 2 SPIRE servers or SPIRE servers that are lower down the stack. And that you can also combine it or either use it separately. The interesting thing is you can federate it as well, right? So you can have multiple SPIRE servers, multiple trust domains saying, hey, trust domain 1 is federated with trust domain 2. And it doesn't really matter, right? If these are workloads, VM workloads, or if these are Kubernetes clusters. I have a couple of resources here. And as I said, we'll post this in the description. I'll post it in a GitHub repo. And this was my presentation for today. Hope you enjoyed it. And we'll see you next time. Thanks, everyone.